Okay, folks, I wanted to show you this cool little boat simulator that I wrote. Basically, what I did was I've got a boat with 6 states, and the 6 states are X, Y, heading, and then U, V, and R, where U and V are velocities, and R is the yaw rate. At the beginning of the day, I kick off and say that the states are all 0, so it's basically not moving, just sitting there. I have some flags here, so I've got animate equals 0, autonomous is 1. So right now it's not going to animate, and it's just going to drive itself. So it's going to skip this loop completely, it's going to set the initial conditions, and then it does a RK4 loop right through here. So if it's autonomous, it's going to compute control. So let's go into this control routine. And so basically what I do is I pull out the 6 states, and then I use a modified PD controller to compute the thing. So basically, I have some proportional and derivative gains for the rudder. An airboat only has a rudder and a throttle, so I command the thing to 5 meters per second with a certain gain, and then I just command a throttle setting. I've got a rudder angle command that basically tries to travel to waypoints. And so where do I set the waypoints in here somewhere? Let's see. XC. Oh yeah, here are the waypoints. So basically the first waypoint is 0, 0, then 20, 0, then 20, 20, and then 0, 20, and it looks like I multiplied by 2, so it's actually 40 meters. So then what I do is I compute my my heading command. So basically it takes where I currently am, differenced from where I want to go, and then I do a wrapping command to get rid of the whole atan2 plus or minus 180. If I get within 10 meters of the waypoint, I switch to the next waypoint, and then I compute that rudder command based on how far away I am from there, and then my yaw rate, and then I assume that the rudder can only go plus or minus 30 degrees. So once I break out of that, I have the control state saved. If animate is turned on, I run this boat animation, but I skip that for now. I call the derivatives routine, so let's take a look at that derivatives routine. So I derived this in my aircraft controls course, so if I do have enough time, maybe I'll post a link to a PDF to the derivation for these equations. But basically there's a bunch of parameters here like mass, air density, radius of the prop, things like that. I've got, fluid dynamic drag coefficients, extract the state, kinematics of the derivatives. Then I've got simple 1D momentum theory for the propeller. I've got velocity and angle of attack on the rudder, lift and drag on the rudder, compute the rudder forces, compute the fluid drag forces on the airboat, and then compute dynamics, and then throw that all into the derivative vector. So I do this RK4 function call here. And then once that's over, basically I just simulate I simulate for 200 seconds. I pull out all the states and then plot everything. I have all the plotting routines here. So I plot X, Y, psi, U, V, R, and then even the control deflections. And I even output it to a state here just in case I want it for some reason. So I'm going to hit play here. And so here everything is. Here's the rudder deflection angle in degrees. Here's a throttle from 0 to 100%. Here's a top-down view of my boat here. Oh, and you know what? Let me. I forgot that I edited my startup routine. So my startup routine, I have all these like default things to make my plots look good. So let me run startup again. And then I can row boat sim. There we go, so now my plots all look nice. So here's my top-down view. So the boat basically starts here and then goes to these 4 waypoints, which is pretty neat. And then I've got my yaw rate, my side velocity, my forward velocity. So remember, it's trying to command to 5 meters per second, so the controller does okay getting there. And then my yaw angle, my heading, is just going around in circles, and then X and Y are just going around in circles. So that's all well and good. But the neat thing that I did was code in that animation loop. And so if we turn animate to on, basically what it's going to do is it's going to run this animation setup. And so basically what I do is I set up the figure. So I set up the figure using this. I give it a name, But then I also do some other things where I actually make a key press and a key release function. And so I should have a key press and a key release. There is nothing in the key release function, but the key press function, what the key press function does is it says it gets the current key from my keyboard. If the up arrow is pressed, I increase throttle. Remember, UK is the control vector by 1. If it's down, I decrease it. And then if I turn left or right, I change the rudder command by 0.1 radians. And so that's what that key press function does. So this sets all this up. I get an X label and a Y label. And then if we go back to my simulation here, everything's the same except now I'm going to actually animate. So if I open up this animation routine, I check and make sure that the real time is going. If not, I say, hey, your time step is too small. I also wait so that it runs in real time. So I do this while loop, and so that way the real time clock can catch up. I extract my state, I clear the figure, and then I do all these patches. So I patch all this stuff together to plot the boat. I plot like the location of the rudder, the thrust vector, I make a title, and then I make a square here. So if we run this now with the animation turned on, it's going to pause, and then I hit enter. And so there's my boat there, traveling. And if once it gets to 40 meters, it's going to turn, and then that's when it starts, following all the waypoints, which is pretty cool. So then it's going to go down to 40-40, and then it's going to turn again. Remember, once it gets within 10 meters of the waypoint, it just keeps going. So again, this is all well and good, but the great thing again is I can turn autonomous to off, and so what happens is it's going to skip this entire routine. And so when I run the simulation now and hit enter, nothing happens. And the reason why is because I need to hit the up arrow. And so as I hit the up arrow, you'll notice that red line is getting bigger and bigger and bigger. And it's because I'm increasing my thrust. And then I can hit left or right here, and I can actually change the direction of the rudder. And so this is an airboat, so it's going to kind of slide because it's in water. But basically I have my own little video game here. With semi-realistic, I guess quasi-steady dynamics here, which is kind of fun. So just wanted to show you some of the cool things that you can do with MATLAB. So hopefully this will inspire you to do something cool as well. Have fun.